accept his advice.
I thank the Labor Lord, the Minister, for his response, and for the Noble Lords who've contributed to this, I think, absolutely crucial debate, particularly the Noble Lords opposite who've put so much into it. And I'm going to, given the hour, I'm going to park aside the debate about Jabal wheat, and perhaps we could have that over the long table sometime or something. We can continue that discussion. I'm going to park that one for the moment. What, however, I'm going to do is say something very serious, and I'd have to say concerning, because the Noble Lord, the Minister, and indeed the Noble Lord Cameron of Dillington both said, and I've no doubt the Noble Lord, the Minister, is operating on the advice he's receiving, that it's impossible to identify if something has been gene-edited. Well, I'm afraid that's simply untrue. And I'm afraid it's a great pity that the Noble Lord, Lord Winston, is not in his place, because I'm attempting to channel Lord Winston and be my best to, he would undoubtedly do this better than I'm going to do. But I am going to refer to, just for one example, an article in Theoretical and Applied Genetics in 2020 under Biswas, Wrong et al. And the title of this article is, quote, "Effective Identification of CRISPR-Cas-Induced and Naturally Occurring Mutations in Rice Using a Multiplex Litigation-Dependent Probe Amplification-Based Method." So, to kind of translate that and put that into English, this article is showing how you can identify both intended impacts of the use of the CRISPR-Cas9 and unintended impacts of CRISPR-Cas9 and any other mutations that occur independent of the use of CRISPR. And this is in rice, for example. But that's just one example from 2020. If we go to another example, there's a commercial practice called real-time PCR method. And I think we've all become very familiar with PCR tests over the process of COVID. And so this is a commercial company. I'm citing what they say. I have no reason to disbelieve it. They say this detects what's probably the most challenging class of gene edits, a modification of just a single letter in the genetic blueprint. So this is the simplest possible change that you can have, and it is detectable through a PCR test, something with which we're all highly familiar. So any claim to say this can't be done, yes?
Baroness, for giving way. Does the company claim that they could tell that single, I think you said a single base pair change, whether that was produced by genome editing or by mutation? Do they say they can and if so, how?
Is a company they're saying it can be tested. I'm sorry, I can't speak for that company. What I can actually refer to, because I've just been reading it, is the Rice article that I've referred to. And as I said, in that Rice article they referred to, which is and as I said, we need Lord Winston really, the multiplex litigation dependent probe amplification method. That article very clearly, and I'll be very happy to provide the reference to the Noble Lord and to the Noble Lord the Minister, says this method can definitely determine whether it's PCR intentional or unintentional, whether it's CRISPR-Cas9 intentional or unintentional, or whether it's something that's happened independently but at the same time. So there is at least this one method here in a respected peer-reviewed journal that sets out how. And going on further from that, I'd point out the fact that the US government this year announced a collaboration to develop, and I'm quoting here, an initial set of computational tools that assists trained analysts to identify genetic engineering in a next-generation sequencing dataset. It makes it possible for scientists to detect engineered DNA at scale. So that's a US government project happening this year. So any claim to say that this is all impossibly difficult and can't be done, I'm afraid that simply just does not stack up. And as I said, if Noble Lord Winston was here, I'm sure he could cite many more cases, but the evidence, I think, is very clearly there. Now, I want to pick up some of the points particularly made by the Noble Lord Krebs and Lord Dillington. First of all, just the Noble Lord Krebs said, we can't have extra labelling, there's not enough space, it's too confusing. Well, I think if we pick up an average packet of something in the supermarket, a packet of pasta, say, you'll have some very large branding on it. and some quite small space that's dedicated to nutritional information another. Possibly you need a bit less space for the branding. I think there's very few packaging that you could look at that there wasn't space for extra information for consumers that we've shown that the consumers want. Now, the points that the Noble Lord Cameron of Dillington made about random mutagenesis techniques and other techniques that are used, and said these are not labelled. Of course, there may indeed be an argument that they should be labelled, but parking that one to one side, the fact is that comparing genome editing to those kind of techniques, it's comparing apples and pears, because basically gene editing can access and amend parts of the genome that are protected from naturally occurring or induced mutations. So this is something I think perhaps we haven't brought out in previous debate, and we might want to explore further at report. But there is a difference between which parts of the genome can be accessed by these different techniques. I think probably I've dealt with quite a lot there, and I'm very, very aware of the hour. I think it's very clear there is a strong demand from many sides of the House for this labelling. There is a strong demand from the public. For the moment, I'm going to beg leave to withdraw this amendment, of course, but I have very little doubt this is something we will return to at report.
This amendment be withdrawn. Amendment by leave withdrawn.